I recently started with chapter 8. We said that our objective is to deal with systems of ordinary differential equations. We were dealing with first order, and we talked about what do we mean by fundamental set, when can we decide or when can we confirm that an initial value problem has a unique solution, which is upon the continuity of the matrix A, each entry in it, and the continuity of f of t if it's not homogeneous. Last lecture, we said that our aim is to solve system of differential equations that have the form x prime equal ax, which is homogeneous. And also we have one restriction on A, that A it contains constant coefficients. It means that we cannot have t in A or sine t or e power t. It should be constant. Of course, A should be a matrix that is a square matrix. That is 2 by 2, 3 by 3, and so on. And we said that we need to apply the eigenvalues method for them. The eigenvalues method, the first step after we write A, we would find its eigenvalues. How do we find its eigenvalues? A minus lambda I, we will find it. How do we find A minus lambda I? We write A on the main diagonal. What do we put beside each negative lambda? And then for the eigenvalues, we go for the determinant, right? So if A is 3 by 3 matrix, we expect to have characteristic equation for the 3. And how many eigenvalues? 3. These eigenvalues, they can be distinct, like 1, 5, and 7, or they can be repetitive, like 1 repetitive twice, and we say that it has multiples 2, and another one that's 5. For the first case, when we have distinct 3 roots, each of these 3 roots, we will find its eigenvector. Each eigenvalue will find its eigenvector. For example, lambda 1 will find its eigenvector as k, lambda 2 as k2, lambda 3 as k3. So if these eigenvalues are distinct, we will get n independent eigenvectors. Each of these eigenvectors combined with the eigenvalue, we will get a solution, k d lambda t. All these solutions are you can. Okay, and each of these eigenvalues must combined with the corresponding eigenvector for it, we will get a solution for it. The combination of all these solutions will be our general solution. In this case, we discussed it. If we go for this matrix, we got here 2 eigenvalues. We got 2 eigenvalues. Each of these 2 distinct eigenvalues, it has its corresponding eigenvector. And then we wrote the solution as x equals c1x1 plus c2x1. This was case 1. Then we went to case 2, which is the repeated real eigenvalues. Do we always have a problem with the repeated real eigenvalues? Let's go back to the algebra. If we have distinct eigenvalues, what will we get? Diagonalization. But if we have repeated eigenvalues, can we deduce something about diagonalization? What do we need to do? Find the eigenvectors, right? So in the case of repeated real eigenvalues, let's say I have 3 eigenvalues, 1 is repeated twice and 2 is repeated once. And suppose that the one that is repeated twice, we got for it 2 independent eigenvectors. Do we have problems? We don't have problems there. And this case, we covered that last lecture with this example. Okay. So the repeated eigenvalues, if you look at this one, the eigenvalue has multiples 2 and it has 2 independent eigenvectors, it's okay for us. We'll get the first solution as k e lambda 1 t, and the second solution as the second eigenvector e lambda t. And if you look at this example, we got lambda equal -1 is repetitive twice, but this lambda equal -1, it has 2 independent eigenvectors, so we are okay with it. And the solution we write it as we wrote it as the first eigenvector E negative lambda T and the second eigenvector E power negative T. Then we solve it for the third eigenvalue. And now is everything clear? Where's our problem then? Our problem is that we will solve. It's not a problem forever. We will solve it. We have an eigenvalue of which multiplicity is 2. But how many independent eigenvectors does it have? 1. It has one independent eigenvector. From this eigenvector, we will get only one solution. But how many independent solutions should we get? So our aim is to find the second independent solution. This one, it reminds us of what? When we have the auxiliary equation, let's say, and we are substituting y equal e of x, and we got m minus 1 squared equal to 0. We say m1 equal m2 equal 1. So can we say the solution y equal ex and y equal ex? How did we remove the dependency at that time? We multiply by x. Here it's similar to it. Y is a function in what? T. So logically, we should multiply the first solution by what? By t. But what's extra here? What's an extra step that we need to do? We have our aim is to find what is. So the first solution we know it is k e lambda 1 t. The second solution it will be of this form. What's the only thing that we don't know it here? K we know it, lambda 1 we know it. What do we need only? P. How do we find P? Remember, miss, how did we find K? The eigenvector, how did we find it? We put A minus lambda I, 0. Right, miss? Isn't it the way that we found K? Okay. Now we need to find P. We will do the same. A minus lambda I. But here, instead of 0, what will we put? Okay. And in this case, we will find. So the solution of this non-homogeneous system, it will give us. Okay, miss? So can we find P before K? What's the first step? Eigenvalue. Eigenvector. Check if it's less than which is required. What do we need to find now? We need to find. After finding K, what do we find? Please take the notes in your own words, and then we will find. Now, what we will do today is that we will consider this case. After this case, we will talk about a similar case where the eigenvalue has multiplicity 3, but only one independent eigenvector. Then we will go for the set evaluation completed, and then we will need only one more case. This one more case, we will finish it on Thursday. For today, we will move to section 7.3 that we were supposed to finish at home. We will discuss it and solve some exercises. Okay, miss? Miss, regarding the question for eigenvalues or this such question, the most important part in that is what? Finding what eigenvalues. It means that when we put a question on the board and we ask you to start with it, please find it, solve it as if you are in the exam, just to practice. Because again, the eigenvalues or this system, solving this system and these one, the calculator will not help us. We need to do practice at home. Did we write our notes? Okay. We will do a direct example on it to make sure that everything is okay. Did you finish taking notes? Okay. This is our question. We are given, we said that the question it can be given as matrix form or it can be given as system. So here it's given as matrix. What's our matrix that is given? It's 2 by 2 matrix, right? This 2 by 2 matrix, how many eigenvalues do we expect to have? 2 eigenvalues. So the first step, we need to find these 2 eigenvalues. In order to find that, we should write A minus lambda I2. How do we write that, miss? The main diagonal, we will copy it the same and just the main diagonal, what will be after it? Negative. So the first step, we need to find the eigenvalues, please. Each together, let's find the eigenvalues. The eigenvalues, it means that we will find determinant equal to 0. So eigenvalues. Determinant A, not I2 equal this one. How do we find the determinant of 2 by 2 matrix? Main diagonal, yes, minus the second diagonal. So please find the characteristic equation. Did all of get lambda squared plus 6 lambda plus 9 equal to 0?
Yes.
Okay. Now, this one is a remarkable identity, or you can solve it using the calculator. If we want to use a remarkable identity, we get lambda plus 3x squared equal to 0. So lambda 1 equal lambda 2 equal to negative. Now, even if we use the calculator, we will know that negative 3 occurs twice, because the calculator will reveal only one answer, and we should have 2 answers. So the second answer, it will be what? Yes. So at this moment, can we decide which subcase? We know that we are in case 2, but can we decide whether we are in subcase 1 or subcase 2? How do we decide whether we need to find as the next step either? Okay. So we are done with the eigenvalues. It is a repeated case. In order to proceed, we need to find its eigenvectors. It has 2 independent eigenvectors. Do we need to go for P? If we have 2 independent eigenvectors, we don't go for P. Okay. Okay, we need to find the eigenvectors now. So the next step, we'll write eigenvectors. How do we find eigenvectors? A minus lambda I equal to 0. This one exactly, it's what? A minus lambda I, we said we get lambda negative 18. We'll have 2, negative 9, negative lambda, and what do we have? So instead of lambda, what should we find? What should we substitute? Lambda equal negative. Substitute and let's check what will be the answer. Question? Okay, what will we get at the Nasser when we substitute lambda equal -3? 6, -18, 2, -6. Okay, miss? Remember, when we are finding eigenvectors, we should get at least one of the rows as what? As now it's clear that one of these rows is zeros because they are multiple of each other. If you are saying it's clear, just keep one of them and remove the other. If not, what will we put? Negative 1/3 R1 plus R2 gives R2. What will we get? The new one? 6, -18. Which column doesn't have leading entry? 6 seconds. So the second, we said that when we are solving this one, we will avoid using x1. We are finding now the eigenvector, it means that k, right? So we will use k1, k2. So here what would be right, please? K2 equal T belongs to R star. Again, what do we mean by R star? It means that T is not equal to 0. Again, why shouldn't we have it as 0? Because it's an eigenvector, and by definition, it's given that it's not equal. So we cannot assume something. By definition, it's not the case. Like a positive number is greater than 0. If I'm telling you I have a positive number, you cannot assume that it can be negative, right? So here this eigenvector is created as non-zero. I should exclude the 0 from it. Okay, miss? What will we get now? Substitute 6 K1. This, by the way, when I'm solving this system, it doesn't mean that in the exam, if we solved it in another way, I would put for you 0. You have the right to use any method to solve it. The calculator will not help. You have to solve it manually, whether you want to go for elimination, substitution, do whatever you want to solve it. But the main thing are the steps, your steps to be correct and the answer to be correct. Okay? But I'm solving it in a way that this way is valid for all questions. Okay, miss? 6K1 minus 18T equal to 0. So K1 is equal to 3T, right? How will we write now the vector, the eigenvectors? 3T, T. We can take in this case T equal 1 is valid. We can take it in common. So what can we deduce here? Lambda 1 equal lambda 2 equal -3. How many eigenvectors did we get for it? The multiplicity of it is 2. What do we mean by multiplicity is 2? It means that this eigenvalue occurs how many times? Twice. How many independent eigenvectors did we get for it? 1. So we got how many solutions at this moment? 1. But how many solutions should we get? 2. So we would write our first solution. Okay? So we found the first solution. We are not done yet because we should have 2 independent solutions because it's 2 equations with 2 terms. Those who finished writing this, write the first solution and try to find the second solution. Did we finish writing from the board? So the first solution of 1 equal the eigenvector that we found, 3, 1, e power lambda t, and e power lambda t is, what's our aim to do? Find x. Yes, we found all independent eigenvectors. So can I find other, from where should we bring other eigenvectors? We don't have, right? So what do we need to write now? In this case, the solution, we said that x2 is equal 3, 1, e power negative 3t, and we will multiply it by plus t, plus e power negative 3t, and we will multiply it by t, right? What's the only thing that is missing here, Miss? What do we need to find? This one we need to find. Okay, Miss? So x2 we have it. The only thing that is missing in x2 to be completed is just. So our aim now is to find questions, Miss. Miss, fill the stack. These ones, they were covered in last lecture. We are okay with it. We put the formula to find x2 because this case is repeated case with one independent eigenvector. Now we will learn how to find t. It's the same as we found k, but instead, Miss, we will write a minus lambda I here. Instead of putting here 0, we used to put 0 here to find k, right? So we'll remove the 0 that is here, and we will put instead of it k. What do we mean by this one? What was a minus lambda I? 6, negative 18. 2 negatives. What was k, Miss? 3, 1. Write the 3, 1 here. Is this one a homogeneous system?
No.
Not homogeneous. Can we solve it using the calculator? Yes, but it will not give us this, right? It will give us math. Why? Because remember, I'm putting a minus lambda I here, and what's the determinant of it? 0. If the determinant is 0, the calculator will not solve it, right? So the calculator will give us answer just if we have unique solution. This one, it doesn't have unique solution. It means that what do we need? Solve it by hand. Okay, solve it. Basically, okay, as we solved it in linear algebra, we will solve it, right, Miss? Okay, how will we solve it? So we will use negative 1 over 3 R1 plus R2 gives R2. The first row, is it changed, Miss? Is the first row changed? The second row, we should get, when we are finding P, we should get a row of zeros because it has to be solved. Okay, Miss? Now, let's remember we are finding P, right? So I will not call them X and Y, I will call them P1P. P1P2. Isn't it easier? But it doesn't mean that you should use the same for K, you can name it something else. But just we are calling, if we have K, we are calling P1, K2, we are avoiding X and Y, not to get confused. Your X and Y in this solution with the X and Y of the system that we are dealing with. Okay? So for this one, we'll call this one as P1 and this one as P. Which one is a pre-parameter here? P. Now, are we finding eigenvector? We're done with the eigenvectors, right? Are we finding eigenvectors? So this T, could it be 0?
Yes.
It's okay to be 0. So I will put, instead of this one, if you want, call it Q. If you want, it's not necessary to call it T. I will put here R. Okay? I will not say R star because R star, if I'm finding eigenvalues, here are eigenvectors. Are we finding eigenvectors? We are just solving T equals 0. It has the right to be T. Okay, miss? What will we get now? 6 P1 minus 18T equals to 3. It means that P1 is 0.5 plus 3T. Right, miss?
60.
18 over 6,
Yeah.
3, right? What will we get P as? It's P1 and P. Please stop running it. What are we saying here? For every real value of T, this P is a function. We need only one P. I don't want all P. In this way, you are giving all P. I need only one P. If I'm telling you I need only one P, take a particular value for T. Which particular value of T do you prefer to take? If you want one, go for it. Write T equal 1. For me, I will take the 0 because I like to see zeros. Okay? So take any value for T. For me, this one, we can take any value for T. For me, I will take T equals 0. It means that T is equal 0.5 and 0. If you want to take T equal 1, you will get 3.5 and. Okay, miss?
Okay, on the same
0.5 and 0 here. If you want to take T equal 1, you will get 3.5 and 1. So this is our P now. Here's substitute. This will be the final answer. But usually, if you have the right to take T any number, I will take T equals 0 d6. If I can take any non-zero numbers, I will take T equal 1 because it's easy. Like in the eigenvectors, we take T equal 1 because we don't have the right to take T equals 0. And this one, if we are solving, T equals 0 is the easiest. Okay, so let's go back to this question. We were given 2 by 2 matrix. We found its eigenvalues. We found that the eigenvalues that we have is -3 and it's repetitive twice. At this moment, we don't have that problem. Then we went and found its eigenvectors. The problem was that I have only one independent eigenvectors and I should get 2 to have 2 solutions. So from this one independent eigenvector, we were able to, we called it as A and we were able to find the first solution. Now we need to find the second independent solution. The second independent solution based on this one is the first solution times T plus vector P times E lambda 1T. So we substituted here. First solution times T, we are okay with it, plus E power -3T times P. The only missing thing here is P. To find P, we will use this one, A minus lambda I K. We solved it in the normal way and we found P. We got infinite solutions. We took a particular, one of the particular solutions for T equal to 0. We got this one P. Now we need to substitute. X2, it was T times X1. X1, it was 3, 1, E -3 each plus What was P here?
0.5 and
0.5 and 0, and it's multiplied by E negative 3. This is not our final answer. What will be our final answer? X equals C1 times X1 plus C2 times X1, it was 3,1 E negative 3T. X2, it was 3,1 T E negative 3T plus 0.50 and here E negative 3. And this will be our final answer, which is again C1 X1 plus C2 X. So this one is C1 C2 X. Do we have any questions, Miss? Okay, let's go back to the question. I will edit it. It's given in this way. I will give it initial condition. What do you want the initial condition to be? 1, 2. What do we mean by this one? It means that the first variable at 0 it will be 1, and the second variable at 0 it will be this one. What do we call this problem now? Initial value. Who can tell me this initial value problem? Why are we sure that the solution of it is unique and it exists? Please remember, when can we say the initial value problem, the solution of it exists and unique? We look at the matrix. The entrance of it, do we have problems there? It means that they are continuous, right? Because they are continuous, it means that the solution exists and unique. We need to find the solution of it. Miss, the solution of it, we will bring it from another question. We will resolve the question again. Already we found the general solution of this ODE, right? So the only thing that is missing, what do we need to find? The values for C1 and C2. From where would we find C1 and C2? From the initial condition value. Okay, Miss, can we start with it? So this is your general solution here. We need to find C1 and C2. C1 and C2, we will find it from the initial condition that is given. Our initial condition is given at 0, 1, 2. Now we need to solve the initial value problem that we have. We set that x0 is equal to 1 to b, right? So instead of p, what would we substitute with? 0. Substitute 0. What would we get from the first one? E1, B1, e power 0 is e power 0, 1 plus C2 something times 0, 0 plus 0.5, 0 here and here e power 0. This one, it should be equal to 1, right, Miss? Muhammad, question? Remove. Okay, what will we get here, Miss? 3C1 plus 0.5 and plus 0.5 C2, right? And here we will get C1. This one equal what? Does it need a calculator to solve it, Miss? Okay, what will be C1 and what will be C2? C1 is equal to what, Miss? C1 equal to, so what's that for? C2, 1 minus 6, -5, we will get -10. What will be our final answer in this case? Instead of C1 here, we'll put 2, and instead of C2, we'll put -10. If we are not given initial value, do we find C1 and C2? So just we found C1 and C2, we would find them in case we have initial condition. Ali, do we have question? Right? Do we have question? Okay, guys. Did we finish taking notes, Smith? Ladies and about finish taking notes? Now, what we will do is that I will give you this question and you will think about it. I expect even those who came late, who joined us late, that you will be able to find eigenvalues and eigenvectors. So the first step that I need for you to do is just to find eigenvalues and eigenvectors, and then we will discuss and start solving. So what's our matrix A, please?
Yeah.
This is our matrix. So A minus lambda I would be 2 minus lambda minus 6, 0, 2 minus lambda 5, 0, 0, 2 minus lambda. The first step, we need to find the eigenvalues, and then we need to find the independent eigenvectors. Please, each one alone find it. Eigenvalues and eigenvectors. This is from linear algebra. What are the eigenvalues that we have? Minus 2?
2.
Minus 2 or 2? 2. How many? What's the multiplicity of this eigenvalue? But at this moment, I don't care about the multiplicity. I need to find the eigenvectors and then we will decide. Okay, miss? So find the eigenvectors. Let's check from the eigenvectors that we will find how many solutions or independent solutions we will get. 3, how many times is it? The multiplicity is 3. Lambda equal to, the multiplicity is 3 terms. We need to find the eigenvector now. Eigenvector is not opportunity. Zeros. And we need to substitute lambda equal to. Okay, substitute, solve it, and find all independent eigenvectors. Who solved it and got the eigenvectors? How many independent did we get? One. What did we get here? 1, 0, 0. Who else other than already we got 1, 0, 0? Yes. Noor. Okay, perfect. How do we continue solving this one? First of all, this one already is row echelon form. Which entry is the non-leading entry or pre-parameter here? This one, if you look column of zeros, the column of zeros, we will take a K1 D. And here we should say E belongs to ours. Then we will substitute K2 plus 6K. Remember this one? K2, K. From this, what can we use when we are solving it? K3 equal to 6. So now we will get K. What will we get here? K at T 0, 0. We can take T in common. So as a summary list or analysis of what we did, that number one equal number has multiplicity 3. It goes to only one independent eigenvector. How many solutions should we get? From this one, which solution? How many solutions? So what do we need to find now? X2 and X. Can we use eigenvectors for X2 and X3? We cannot.
They would be the same answer.
Yes, which is meaningless because they should be what? Independent. So we got the first solution, still we need to work out for 2 other solutions. Of course, we should multiply by T, but is it alone sufficient to do that? What did we make in the previous part when the multiplicity was 2? We multiplied by T and we found P. So here for the second solution, we will do the same as the previous one. We will talk about the first solution. We will have this score.
Yes.
But at the moment, we need to find only the second solution. So we have the first solution. Our aim now is to find the second solution. Go back to the previous part and check how did we find the second solution. Okay, let's write the formula for the second solution. So we have here x1. What do we need to find? X2. After x2, we find. So add this moment, we need to find x2, which has the same steps as the previous. How do we find the second solution? X2 is equal to x1 times t, right? X1 times t. What's x1? 1, 0, 0. E power 2t. And we will multiply it by plus e, and this one it should be determined. E power. Now our next step is to do what? Find this. How do we find P from where? From K. Okay, miss? So how do we find P? A minus lambda I, and here we would put A. A minus lambda I equals 0.16.005 and 0.00. Here instead of 0.00, we will put K, and K in our case is 1.00. Solve this one. What do we call these ones instead of K1, K2, K3? Please solve this. You get the system, Miss, right?
Yes.
What's P3?
Two.
Okay, and P2 it will be?
One.
Okay, what will be P now? P is equal to what, Miss? P, then
1-0.
0, right? So P is equal P 1, 0. What's the easiest thing to substitute P as? If I want to substitute it at 0.5, it's okay. As 100, it's also okay. But always we think about what's the easiest thing, especially that here, this is not our final answer. We still have one more step, which is what? X. So we'll substitute P equals 0. This one means that P is equal 0, 1, 0. And X2, it will be now T 1, 0, 0, E2 T plus 0, 1, 0, E. Done with X2. Are we done? Till now, we got how many independent solutions? 2. Is it enough? How many equations do we have? 3. Okay, so we still need a third independent solution. Let's go back to ordinary differential equations that we substituted and then y equal e m x. In the auxiliary equation, we got m minus 1q equal to 0. So m equal 1 is represented how many times? So we'll put ex, xex, and then x squared. So in x3, what do we expect to have instead of t? T squared s. Okay, miss?
Define P or
Okay, already we have P. What do we need to find? A third factor. The third factor we will call it as, or call it as. How do we find the third solution? This one, it makes sense. K, we'll multiply it by T squared over 2 and put this one plus PT E lambda 1 T plus Q. The only thing that we need to find is what? And Q logically, how will we find it? A minus lambda I. If I put K, I will get P. But what do I need? Q. So what will be equivalent? So this one for Q, we'll use it. For P, in order to get P, we'll put K. In order to get K, we will put the zero factor, yes?
P square?
This is the formula. Now, how did we get this one? Because this one, it's also when we are adding it to something in the P, the answer it will be half. We'll check. So what do we need now to find this? Now, the next step, what do we need to find this? X3. Okay, so X3, let's write the formula for it. 3 it is T squared over 2, 1, 0, 0. Yes, this is K, E to T, plus P it was 0, 1, 0. P, we said that we'll multiply it by T, and then plus
Q.
Q, E to T. What's the only thing that we need to do here?
Q.
Find this Q. So how do we find this Q, miss? We will put here P. What was P? Okay. And what was this one that is here? 0, 1, 6, 0, 0, 5, 0, 0. This one we'll call it as Q1, Q2, and Q3. Okay, please solve it, miss, and give me the answer. I will take the final answer from you for Q.
What is the two square over 2?
The formula for X3. Okay, just to guarantee that they are independent on each other. Now, how did we reach the formula? You can search for it, and if you don't understand it, I will explain it here.
I'm changing the T, I will put 0.
It's easier for you to keep it in So here we will get Q2 plus 6 Q3 equal to 0 and 5 Q3 equal to 1. So Q3 is equal to 1 and Q2 negative 6 over 5. Did all of us get this answer, miss? Did we get this answer?
Yes.
Okay, what would be Q, miss? T? 1 over 5 down, right?
Yeah.
Q2, we got it as
Yeah.
negative 6 over 5. So the easiest thing to substitute is T equals 0. We will get Q equals 0, negative 6 over 5, 1 over 5. And then we will substitute, right, miss? We will substitute in X3, and finally, after substituting, we will write X equals C1 X1. Do we find C1, C2, and C3 miss?
No.
Because it's not an initial volume problem. Any questions, Hans? Okay, did we finish writing from the board? Okay, so let's recap. So our main objective, it was to Khalid, it was to solve systems of the form X prime equal AI. It doesn't mean that we learn to solve any system. We have here constraints. It's homogeneous. The matrix A is square matrix, plus the entries are constants. It means that I don't have an X sine T, cosine T, and these ones, and it's circular. The method that we were applying is eigenvalues and eigenvectors. The first step, what did we find? Eigens. If all of them are distinct, we go for the eigenvectors and we write the solution normally. Okay, repetitive, what will we do? We will check if independent eigenvectors or we don't have enough eigenvectors. If we have enough independent eigenvectors, we will find our solution accordingly. Unless if we have multiplicity 2 and 1 independent eigenvector, we will find only P. If we have multiplicity 3 and 1 independent eigenvector, we need to find P and then P. Okay. Still, we have one more case to cover, which is about the complex. The complex, hopefully, we will do it on Thursday, and it will be hopefully we will be able to finish the material on Thursday. And next Tuesday, we will solve exercises. You can bring also exercises with you. At this moment, revision on the next Tuesday. Not revision, it's just like to make sure about each idea we are okay with it, and we can create a question also. Okay, but I will not prepare a revision and bring it to the class. Okay, unless you have questions, you can share with them ahead of time. Now, what we will do now is that I need all of you to open your Blackboard. There is that evaluation for our course. The first thing, do the survey now. Once you're done, just raise your hand. When you are done, it doesn't mean that you will leave the class. We will continue discussing the last part of the section 7.3 that was proposed as homework to discuss at home. So just open Blackboard, tools, surveys, choose the set evaluation of our course, do it, and I can check how many are doing it right now. Okay, I cannot know the names, but I know if you are done with it or not.
Still rates.
completed it at homes? No one?
There's no kind by tools.
From tools surveys. Who completed it from villages? If we completed it, let me just check this one and we can do something else. Now, there are other surveys that they are on university level about your satisfaction regarding registrations, scholarships, and these ones. Have we finished them? Okay, can we finish them at home or when you have break? This is very important, Miss, to put our input. It's anyways anonymous. So in the university, they will not know that you are not okay with the registration or whatever if you do not tell them. Finish this one. Did you prepare this one at home? Did we go through it? The file should be with you on Teams. Please open it on the unit step function. And we need the slide to understand that. We need also the slide 41 and 42. So we need slide 35, 41, 42, go through them right before we listen them so that we can apply. That's here. Wala, she's not here. Fatima here. Maryam. Maryam is here. Khaled is here. Mark is not here. Muhammad Nader is here. Hamad Abdullah, Said is not here. Mahsen is here. Talal here. Rashid here. Abdel Nasser here. Ali here. Muhammad here. Hamad Ishaq is here. Basil is not here. Hamdi is here. Abdelaziz here. Shahid is not here. Shiriniyo is here. Abdel Ghani. Hamad Siddiq. Harun is not here. And Amir is not here. Haven't completed it yet, Miss? Who did not complete it, Miss? So all of you completed it? You said survey, okay. And you received confirmation that you completed it? Anyways, I assured an announcement in case you did not do it, so we can do it at home. And let's continue now to start. We already explained the class transform, and we said that whenever we have formula for the class transform, we'll have another formula for the inverse Laplace. Now, why do we need formulas? Because at the very end, we are applying it to solve a linear differential equation. By definition, Laplace transform is an integral. So instead, if I have a formula for the exponential, a formula for the sine or cosine, why each time I have a question that contains sine, I will go and do the integral again. Okay, so just we will apply formulas that. And previously, we discussed the first translation formula, and we kept the second translation formula to prepare at home, and we said that we will discuss it. So we'll not go and explain it in detail. So we'll put the formulas. We will apply them in. But first, what do we mean by unit step function? It's a piecewise defined function. Now, if we have a piecewise defined function, we are able to find this Laplace, but not using a formula. We need to integrate, right? So we can integrate this one and get the Laplace of it. As an example, what do we mean by this one? For example, if I have ut minus 2, what do we mean by it? It means that it's either 0 or 1. It's a step function. Step. Okay, so if t is between 0 and 2, I will get the 0, and if t is greater than or equal to 2, I will get it as 1. Now, Laplace of this one, we can go for the integral and find it, or immediately we can apply the formula. So if I'm giving you Laplace of u of t minus pi, for example, should I go and integrate? We can integrate if we want, but we can apply this formula over S, and instead of A, what would we put?
Right.
So this is the first formula that we need to. This one, if you have just ut minus 1. Now we need to learn if I have a function multiplied by ut minus a, how do I find its Laplace? And if I find its Laplace, I need to understand what the Laplace is. Now from this one, whenever we have a formula, we said that about Laplace, we will have also another formula for Laplace one. So if we are asked, find Laplace inverse of this one, it will be what? ut minus. Okay, miss? So if you want Laplace inverse of e minus 9s over s. This one, it will be equal to what plus? ut minus what? Ut plus or minus 1. Okay, so look at this one plus. This is always minus a, always minus. You don't have a plus here, plus it will be wrong. Okay, miss, any questions about the first idea that we have here? There are 2 boys here or 3 boys that did not complete the survey. Are you sure that you received the confirmation? All of you? And also Hira and Maya, you did not complete the survey. The second formulas that we need to know, don't. This formula. I will write them. I will rewrite them. So Laplace of ut minus a at e minus a is equal to e negative as multiplied by s. Just instead of e negative as over s, we will have instead of 1 over s and 4. So this one, what does it mean? Laplace inverse of this side equal to what? ut minus a multiplied by f of t minus a. Please write the formulas. After writing the formulas, think about this exercise. Let's compare. This one is Laplace, so we need to check which formula is this one. Which formula is?
Second.
Okay, let's analyze it. This is minus a and this is minus b. So what's a in this case? What's b in b? A should be positive. It cannot be negative. Okay, so we put minus 2, but we take just positive. So this is our first step. This is A. Now, f of ut minus 3, we have it here. F of t minus A. This one is f of t minus A. So what's f of t? F of t minus 3 is t minus 3. So f of t, t. F of t minus 3 is t minus 3. So f of t, you got this. F of t minus 3 is equal t minus 3. So f of the apple is the apple. If I put instead of this apple t, I will get f of t equal to t. Abdelaziz, is it clear?
Yeah.
And let's compare this one to the pink that is here. Ut minus a, you have it, right? So after comparison a, it will be ut minus a, and you have ut minus 3. So what's a? Ut minus a, and you have ut minus 3. So what's a? Minus 4 plus. So here I have minus a, and here I have minus 3. So a is 3. What's left, miss? We are left at t minus a, and we are having here t minus 3. So at t minus a is the same as t minus 3. So t minus 3 is f of t minus 3. Okay? So what's f of t? T. So we wrote. The answer of this one is e minus af. That's right. Right now? Instead of a, what will be put? What f of s? F of t is equal to t. So what will be f of s? Go back to the formulas that we wrote. It's even Laplace of t 1 over s or 1 over s squared? 1 over s. I will give another example. Let's just write it down. Try during the week and to go through the material again. We have only chapter 6, 7, and 8. We don't have that much, and it doesn't require that lots of integrations or derivatives. There are methods, and we need practice. Of course, we need to understand why we are using it. Already, we should be understanding it in class. Now we need to do practice side. And then everything that you are facing problem and highlight and put it in a note and bring it with you on Tuesday. Okay. Let's see, my office hours will stay till the last teaching week. After that, I will not have office hours anymore. Anyways, we'll have the exam immediately on Monday, our exam. And on Monday, I cannot guarantee that I will be free for questions because I may be having meetings or other more practical things. Okay, miss? You'll be fine. You'll be fine, but I will not solve the exam for you. So just in case you have questions before, you should ask. Okay, miss? Just to make sure that this one is clear for us, let's check this example. Plus, would you like to use exponential, sine, sine, cosine, or cosine? Which function would you like to use? Sine. Sine. T minus 3 or 7. And here I will put u t minus 7. Again, miss, we will compare it to what? Laplace of f of t minus a, ut minus a equal to e minus a f of. So first of all, identify your f, identify your a. What's our a here, miss? So right, A equals. Minus 7 here and minus A here. All of us agree that A is equal to 7. All of us are able to see that A is equal to 7. Let's look at the blue part now. F of T minus A is equal to sine T minus 7. This A, what did we say that we will put instead of 7? Didn't you tell me that A is equal to 7? F of T minus 7 is equal to sine T minus 7. So what do we have? F of something is E. Sine of this something. Do we agree? Right.
Yes.
What will be F of T minus? I need from you now to find F of F, which is Laplace of F of T, which is Laplace of sine T. Laplace of sine T, we can find it using the table that we have for Laplace. What's Laplace of sine T? A or K over square. What's our K here? K for this one, 7. 1 over a square plus 1. What will be the final answer for this one now? E minus over a square plus 1. Is it clear, miss?
This, the last of
We need to memorize the tables of Laplace of T, like T power.
the whole one.
This one, the formula exists. These 3 formulas, this formula and its inverse Laplace, we should know it. This formula, we should know it. If you know this formula, it means that you know this formula, I will explain it again later. Okay, now we are applying these 2 formulas, and already we applied this formula that is here. Any question? Let's do now. This is the only question that we have. The Laplace inverse of F is easier than the Laplace.
So it's always when F of T minus A, we always put T minus A as T. Always.
Yeah, but the idea is that what if I gave you this one, we will handle this in the second formula. If I give it to you sine T ut minus 7, you cannot apply this formula. We will talk about this.
No.
I cannot compare this. But at this moment, we don't care about it. We care about understanding this one, and then I will move to the one. Now, miss, let's check Laplace inverse E power. What do you want the power to be? -1. Something times x, which number do we like? 2 and 1. 5.
5.
Okay, 4 I put it because 5 it will be the same as add. I will multiply it by, let's make it s a square minus 1. Okay, let's try this one first. Think a little bit about it. We will discuss it. After I make sure that we understood it, we will give an example to solve it out. We have e power negative as e power negative something as. It means that we are applying here the translation formulas, which is the second translation formula. So the first thing we need to write the formula that we have, Laplace inverse of E negatives AF, F of F is UT minus A, F of E minus A. And we put it in a box. Compare now. What's our A? Are all of us able to see that A in our case is equal to 4? What's remaining? So we have this one miss, and we have this one. So F of S is F over S square minus. From this one miss, what can we find? F of T. This one is what?
Okay.
Yeah, F of T is equal to what? Cosine of what?
Okay.
10T. Do we agree? This one from the table. This we have to go to the table and take it from there. Okay. Now this one, miss, that is here. This one that is here, it is UT minus 4 F of T minus. Do we agree? Do we agree, miss?
Yes.
Okay. UT minus 4, I will keep it this way. I don't have F of T minus 4, but what do we have instead? F of T. So cosine, instead of T, what will we put? T minus 4, and this will be the final answer. Now, if you look here, the Laplace inverse in this case is easier than the Laplace, right?
Should we change the 4? The A.
Here is cosine 10T. I don't care about the 10. Just this T, this ample T, I will put bracket and put instead of 15. And you can keep it this way, no need to expand.
Get the cosine 20.
Please open the formulas that we wrote about Laplace. About Laplace inverse. We wrote a table. I asked you to write it. While Mohanad is searching for the table, please think about this exercise. Laplace inverse of Can we think about this exercise, miss? Yes, Mohanad. Did you find it? Do you have the table of Laplace inverse? Please. You sent it in Teams. It's on Teams now. Mohsen sent it. Can you open it? Laplace inverse. Before S square or S over S square minus J square. S over S square minus J square. What's the Laplace inverse of that?
Cosine 3.
Oh, so let's compare this one. Here, what do we have? S over S square minus 100. So K square is 100. It means that K is what? 10. So it's cosine 10. Did we get it now, Mohanna? Okay, Miss, please, if you are okay with what we explained before, please think about this exercise. We can solve it in pairs. Okay, what's our A here?
Five.
Five. So all of us agree that it's five. Okay, so A is equal to five here. So this is our A, right? And f of S is what? Okay, so I need from you to go to the Laplace inverse table and find f of t. So we need f of t here is equal Laplace inverse of 1 over n power 1. It's equal to what? T power 8 over 8 factor. Did all of us know how to find this one, miss?
Yeah.
This is from the table, right? So this one, it would be equal to what? U t minus a, and instead of a, we will put, and what will we write here also? F of t minus ut minus 5, you already have it.
Yeah.
We have f of t, miss. So f of this apple is the apple power 8. So what will we get here? The apple power 8 over 8 factorial. And instead of this apple, we will put
T minus.
t minus. This do not simplify or expand or whatever. This answer is accepted. Please keep it in this way. Do you have questions, miss? Any questions? Did you finish writing from the board? Okay, yes, I will soon end. I need to start with the blue equation. We need to solve it using Laplace transform. Should I zoom it more? I can be back. This is okay now. Are you able to see it? We can solve that H together. Go back to the material. How do we start? Laplace both sides. And we should say that Laplace of small y, we will assign it as capital. What's the plus of ut minus 1 over s, right? I don't need the s. E minus s over s. A is equal to 1, so I'm going to say it's E minus s over s. Because you will get E minus s on the right hand side. So the whole answer will be in terms of what ut minus a, which is here in the case ut minus 1. So we will get always ut minus 1 times something. So we got on the left hand side s squared minus 5s plus 6. And what did we get on the right hand side?
S square y.
Yeah, on the left hand side, you got s squared y. Okay, so I should bring the plus 1, right? Did we get this one, miss? Miss, when we have e power negative s and we have something without e power negative s, don't do common denominator. If the one that contains e minus s alone and the other one alone as well. What will we have y now at? E minus s over s. This one, how can we write it? S minus 2 to s minus 3, right? Right, miss? And this one, okay, miss. This one, do we know how to find the Laplace inverse of it? We need the partial fraction here, right? A and B, and you'll find the partial fraction. Now this one, miss, how will we find it? Think about this one. This one, I know that you can solve it. We solved lots of exercises like it. We need this one now. What's the difference between these two ones? Just E minus S. So what is f of s in this case? 1 over s at minus 2 at minus 3. What do we need to find for this f of s? F of t. How? Using what? Partial fraction. What's a mean in this case? 1. So the answer that we will get, we will put f of t minus 1 and we will multiply it by ut. Please go with us. Somebody just to explain what we need to do. We have Laplace inverse e negative f over s minus 2 and s minus 3, right? So what's f of s in this case? 1 over s minus 2, s minus 3, and this one is equal to ut minus 1, f of t minus 1. What do we need to find? F of t minus 1. Find f of t minus 1. What do we need to find? F of t. How do we find it? It's Laplace inverse. This one, how can we write it? So it's Laplace inverse of a over f plus Laplace inverse. Do we know the Laplace inverse of each of them? What's Laplace inverse of the first? T or A? A. Of the second? And the third? When we substitute them there, instead of each t, what should we put? T minus 1. Okay. And how do we find ABC? It's partial fraction. So we need to study at home. So not attending here and not studying at home, this one, they don't work. And you cannot ask at the end that I did not understand the question. So I expect to still have time on the mean and please go through the material, highlight the ideas that we are facing some problems in, and we will solve, we will re-explain them hopefully next week and solve in class more exercise. Please, do we have any questions for today? Okay, so on Thursday we have a lecture. I will try my best to finish on Thursday lectures so that on Tuesday we have time for solving exercises and on Thursday for 2 days. Have a nice day, Miss. I see.